Greetings. In this video, I will present about modern Android app architecture. Android applications are made up of multiple components such as activities, fragments, services, content providers, and broadcast receivers. These components are declared in the app manifest, allowing the Android OS to manage them and integrate the app into the overall system. Since users frequently switch between apps and mobile devices have limited resources, the OS may terminate and restart app components at any time, and not necessarily in order. As a result, Android apps must be decided to handle dynamic workflows and unexpected lifecycle events, avoiding relying on in-memory data or tightly coupled components. Let's start with a common architectural principles. There are four principles. First, separation of concerns. Avoid placing or logic in activities or fragments. These components should only handle UI and system interactions. Keeping them minimal improves testability and avoids lifecycle related issues. Second, dry UI from data models. UI should reflect data from independent data models. Use persistent models to retain data across app restarts or system shutdowns. This approach supports offline use and increases robustness. Third, single source of truth. Each data type should have one owner that manages it and exposes it. Other components access this data as read-only. This improves data consistency, traceability, and prevents bugs. And fourth, unidirectional data flow. Data flows downward, such as from model to UI. Events like user interaction flow upward to the SSOT. This one-way flow ensures better state management and simpler debugging. Next, recommended app architecture. Each application should have at least two layers. First, the UI layer that displays application data on the screen. Second, the data layer that contains the business logic of your app and exposes application data. And third, which is optional, the domain layer can be added to simplify and reuse the interactions between UI and data layers. This modern app architecture encourages using the following techniques, among others: a reactive and layered architecture, unidirectional data flow in all layers of the app, a UI layer with stakeholders to manage the complexity of the UI, routines and flows, and dependency injections based practice. Start with the first component, UI layer. The role of UI layer or presentation layer is to display the application data on the screen. Whatever, Whenever the data changes, either by user interaction or external input, the UI should update to reflect the changes. The, the UI layer is made up of two things. First, UI elements that render the data on the screen. You build these elements using Wave or Jetpack Compose functions. Second, stakeholders such as view model classes that hold data, export it to the UI and handle logic. Second component, data layer. The data layer of an app contains the business logic. The business logic is what gives values to your app. It's made of rules that determine how your app creates, stores, and changes data. The, the data layer is made of repositories that each can contain zero to many data sources. You should create a repository class for each different type of data you handle in your app. For example, you might create a movies repository class for data related to movies, or a payments repository class for data related to payments. Repository class are responsible for the following tasks: exposing data to the rest of the app, centralizing changes to the data, resolving conflicts between multiple data sources, abstracting sources of data from the rest of the app, and containing business logic. Each data sort class should have the responsibility of working with only one sort of data, which can be a file, a network sort, or a local database. Data sort classes are the bridge between the application and the system for data applications. Third, domain layer. The domain layer is responsible for encapsulating complex business logic or simple business logic that is reused by multiple view models. This layer is optional because on the app we have these requirements. You should use it only when needed. For example, to handle complexity or favor reusability. Classes in this layer are commonly called use cases or interactors. Each use case should have responsibility over a single functionality. For example, your app could have a get time zone use case class if multiple view models rely on time zones to display the proper message on the screen. Next, manage dependencies between components. Use either of the following design patterns to gather the dependency of the particular class. Dependency injection or DI allows the classes to define the dependency without constructing them. At runtime, another class is responsible for providing this dependency. Server locator. The service locator pattern provides a registry where classes can obtain their dependency instead of constructing them. It's recommended to follow dependency injection patterns and use the Huge library in Android apps. Huge automatically construct objects by walking the dependency tree, provides compile type guarantees on dependency, and creates dependency containers for Android framework classes. Next, general best practices. Here are 8 practices. First, don't store data in app components. Second, reduce dependency on Android classes. Third, create well-defined boundaries of responsibility between various modules in your app. Fourth, expose as little as possible from each module. Fifth, focus on the unique core of your app so it stands out from the other app. Sixth, consider how to make part of your app testable in isolation. 7. Types are responsible for the currency policy. And 8. Persist as much relevant and fresh data as possible. What are the benefits of the architecture? It improves the maintainability, quality, and robustness of overall app. It allows the app to scale. More people and more teams can contribute to the same code base with minimal code conflicts. It helps with onboarding, as architecture brings consistency to your project. New members of the team can quickly get up to speed and be more efficient in less amount of time. It is easier to test. A good architecture encourages simpler types, which are generally easier to test, and bugs can be investigated methodically with well-defined process. Conclusion: a solid app architecture is essential for creating scalable, maintainable, and robust Android applications. By following common principles such as separation of concerns, unidirectional data flow, and utilizing layers like UI, data, and domain layers, you can ensure that your app is easy to manage and test. Proper architecture enhances code readability, supports collaboration, and simplifies debugging, leading to more efficient development process and a better user experience. And that's it. Thank you for watching.